Good day. I am here to discuss or share with you about the conversion of infix to postfix and the conversion of infix to prefix. So, let's start. So, before we convert or do a conversion from infix to postfix and infix to prefix, let me first share with you the basic things that we need to know regarding with writing arithmetic expressions. So first, here are the operands, such as A, B, C, D, and so on. So these letters are what operators perform, or operands also could be numbers such as 1, 2, 3, and so on. The next is the operators. So the operators includes the plus sign, the minus sign, the division, and the opening and close parenthesis, and the multiplication. So in other words, the operands are the letters or the numbers, and the operators are the symbols that performs operations in our operands. Then now, let's move on to the three notations, which is our main topic for this video, where we convert infix to postfix, infix to prefix. Now, let us first know what these are. Now, first here is infix. So, infix is a notation where operators are written between operands. So, for example, here, B plus C, here is the operator, which is in between. Then the two operands B and C, and that is the infix. Next is the postfix. The postfix is a notation where operands precede operators. Operators here are written after the operands, but postfix still does the same from infix. So like it still do addition with these two operands, and it's just that the operator here is in between, where here is after. Now next is the prefix. It is still a notation. So from the word pre, now this time the operator is written before the operands. For example, here plus BC, so the operator here is written before the operands B and C. Now we already know the difference with these three terms. Now let's start doing the conversion of infix to postfix. So here we have the precedence in which the power comes from right to left. The next is the multiplication, and the division here comes from left to right. Then the addition and subtraction comes from left to right also. So here, where left to right means to push the incoming operators, while the right to left means to pop the top of stock and push the incoming operators. As we can see here, we have the algorithm or the steps to follow in converting infix to postfix. Now let's go directly to our example. So here is our expression, and let's follow here the algorithm. So first here, the first character in our expression is letter B, which is an operand. So as I've said earlier, an operand is a letter or a number, while the operator is a symbol like plus sign or minus sign. So let's start, no? So here, letter B is an operand. So let's go to our algorithm number 3. I'll read the number 3. If the character is operand, add to postfix. So let's put the B here first. Then let's put the character B. B here in our postfix. Next is an operator, which is the minus sign. Now, since here in the algorithm 4, if character is operator and stack is empty, push operator to stack. Now, let's push the operator to stack. So, let's put here the minus sign. Then here is a stack. Then, let's copy the letter B. Next is an open parenthesis. So, let us always remember that if we come across an open parenthesis, just push it directly to the stack and it would look like this. That. Now next is the operand C. So here, if the character is an operand, let's directly add it to postfix. Now let's just copy this and then add C here. Next is the multiplication. And here, let's go directly to the algorithm number 5, which is if character is an operator and stack is not empty, compare operator with the top element of stock. And since our top element of the stock is a parenthesis, and it is not included in our precedence here, so the character multiplication will be pushed directly to the stock and it would look like this. The next is the operand D. Since it's an operand, let's add it directly to postfix. Now next is the operator plus sign. So here in algorithm number 5, from if character is operator and stack is not empty, compare operator from the top. So here in algo 6, if top is greater than the operator, pop and push the incoming operator. So in here, our top is a multiplication in our precedence. Now, multiplication is higher than the addition. So what we're going to do is that to pop the multiplication, then push the addition. So it will go like this. Then push the addition. Then here is to pop the multiplication. Now next is the open parenthesis. So let's just copy this and then paste. The next is the E. Since it's an operand, let's just copy this also, then paste it here. Copy this. The next is the division operation. In here, since our character is an operand, an operator, and our stock is not empty, so let's compare the operator with the top element of the stock. Now here, in our stock is a parenthesis, and parenthesis is not included in our precedence. So division operation will go directly to the stock and it will go like this. Then BCD times E. Now next is the character F. Since it's an operand, let's just copy this directly, then paste. Then add F to postfix. Now next is the addition operation. since this is an operator and our stock is at empty, let us compare the operator with the top element of the stock. And since our top element here is a division operator, which is greater than the incoming operator, then the division will be popped and the addition will be pushed, and it will go like this. The next is G, letter G. Since it's an operand, let's just copy this and put it directly to Postfix. Now next is we have the close parenthesis. In here, it is different. Whenever we come across a close parenthesis, all we have to do is pop out all the operators until it reaches the open parenthesis. Since here, our only operator is an addition, so it will be pop out. Then it will be like this. Then the postfix BSIT. Now next is the multiplication. So since it's an operator, let's compare our operator to our top element of stock. In here, we are comparing the two operators. The close parenthesis will go off if our top element is less than the incoming operator. Then it will be pushed directly into the stock. So next is would be the character H. Since it's an operand, let's just copy this and push it here on the postfix. Then add the letter H. Next is we have another close parenthesis. So in here we have two operators used. Again, we should always remember that if we come across a close parenthesis, we have to pop out all the operators until we reach an open parenthesis. So in here, we only have one operator, and one operator remained, and which is the here the subtraction. Sorry. Since we are going to get this and then this and then last in first out, so it will be like this here. The next is the multiplication. Now since it's an operator and it's greater than the top element of the stock, so it will be pushed directly and it would go like this. Then lastly, the A, since it's an operand, let's just copy it directly, then push it into the postfix. And now that we are done in all our expression, let's go to our algorithm number 7. Now repeat 4 to 5 until all are scanned. Since all of these or each of the character here in our expression are already scanned, let's proceed to algorithm number 8. Now if stock is not empty, pop all elements. As we can see here, we still have the two operators, the subtraction and multiplication in our stack. So all we have to do is to pop. Therefore, our final postfix would be BCD last in first out, so times minus. So this is our final postfix, and that would be all for the infix to postfix conversion. Now let's proceed to the conversion from infix to prefix. Now here, infix to prefix is just the same as infix to postfix. However, there's only one difference between, which is when we are going to convert infix to prefix, the expression of infix to prefix would be reversed. Where here, we have to reverse this expression, then it would be 9 to the power f plus e so this is the reverse. Now let's also follow the algorithm or the steps here provided. Now move left from right, then initiate empty stack. Since our stack is empty, let's go directly to algorithm number 3. So here our first character is an operand, which is 5. Now let's add it directly to postfix. Next is f, which is an operand. Now we're just going to copy this. Next is the addition. Now, since it's an operator and the stack is not empty, let's compare the operator with the top element of stack. And since our top is power and our incoming operator is addition, and if we look at in our precedence, the power has the highest property. So in here, it would be the top element. The top element will pop, and the incoming operator, which is the plus sign, would be push. So here, would be here would be the addition. Then 9f power. Now next is e, the element e, the character e. Now since it is an operand, we're just going to copy this, then e. Now next is the multiplication, which is an operator, and it's not empty. Now we will check if the top element is greater than the operator. And since the top element is less than the operator, then this operator would be pushed to stop. Here is 9f power e. Now next is an open parenthesis. As what I've said earlier, it will be pushed directly to stop, and since it's not included in our precedence. Now let's just copy this. Now next is the character D, which is an operand. Now let's just add it directly to postfix. Now copy this, then paste D. Now next is a power operator. Then add it to the stock. Then next is the character B, which is an operand, and let's just copy this. Then B. The next is the addition, which is an operator, and our stock is not empty, so we will test if the top is greater than the operator, where top is the power, and the incoming operator is the plus sign. Now obviously power is greater than the addition because what I've said earlier, the power has the highest priority. So now all we have to do here is pop out on the top, then push the operator, remove this, and push the operator, then pop the top element, which is the power. Next is the operand A. Therefore, let's just copy this. Since it is an operand, let's just copy it directly. Then A. And now lastly, our last character, which is the close parenthesis. And what I've said earlier, if we come across a close parenthesis, I said it again and again, all over again. All we have to do is to pop all the operators in the stock until we reach the open parenthesis. Now here, there is only one element, which is the addition. Copy this, then remove this, and add it here to prefix. And now finally, we are done scanning each of the character here in our expression. Now let's go to algorithm 8. If stock is not empty, pop all elements, which is here our stock has still two operators. All we have to do is to put it to the prefix. So then with the method of last in first out times. So in here, since what we are doing is the conversion of infix to prefix, we're here in our infix expression, we reverse it. So in our final output, we must reverse it too. So now it's gonna be plus times and that would be the final output of our expression from infix to prefix. And now we are finally done. Thank you for watching.